Welcome to the Deep Dive. Today we're tackling a really critical area, API gateway security. Honestly, it's essential stuff for anyone dealing with modern digital systems.
Absolutely. And it's great because, as a product manager at SEEBURGER, you bring that practical, real-world view on API management right to our listeners.
Exactly. Having seen it up close, it's clear this isn't just for the super technical folks anymore, so let's quickly define it. An API gateway. Think of it as the main gatekeeper for your APIs.
Right. It manages all the traffic coming in, handles who gets in authentication, authorization, and makes sure security rules are followed. It's that central checkpoint.
Like the security desk in a big building.
Yeah.
And modern gateways, like the one SEEBURGER provides, they give you really important visibility into what's happening.
Totally. So, our mission today, to really get why the security aspect is so vital and what the key measures are, especially with threats changing all the time.
We'll get into specific policies and some of the newer approaches too, right?
You bet. We'll cover the practical stuff needed for a solid defense.
Okay, so let's dig in. Why is an API gateway so important for security? What's the big deal?
Well, look, without it, every single one of your APIs is basically exposed. Directly. It's like leaving every door and window in your house unlocked and unguarded.
Yeah, not a good idea.
Not at all. The gateway is that first crucial defense layer. It's specifically designed to handle the kinds of attacks APIs face today.
And there are some pretty well-known threats, aren't there? I think there's a list. OWASP?
That's the one, the OWASP API Security Top 10. It's basically the definitive list of the biggest risks out there. We don't need to go through all 10 right now, but it shows exactly what a good gateway helps protect against.
Okay, so give us a couple of concrete examples, things a gateway helps stop.
Sure. A really common one is broken authentication. This is where the way you check who someone is, maybe it's weak or just missing altogether.
Like using password 123?
Haha. Yeah, or worse. The gateway steps in to enforce strong checks, make sure only verified users even get close to the API.
Got it, like a solid ID check. What else is...
Another big one is unrestricted resource consumption. Think denial of service attacks. Someone just floods your API with requests.
Right, overwhelming the system so legit users can't get through.
Exactly. The gateway uses things like rate limiting, we'll talk more about that, to cap how many requests can come from one place. It keeps things stable and fair.
So it protects the system from being hammered, basically.
Ridiculously. And then there's the risk of unrestricted access to sensitive business flows. APIs often connect to really critical business functions or data.
You don't want just anyone poking around in there.
Definitely not. The gateway lets you set up very specific rules about who can access what. Fine-grained control based on need.
That sounds critical. Getting access to core business logic seems like a nightmare scenario. One more.
How about security misconfiguration? This is huge. Simple mistakes in setup, default passwords left on, systems not patched, security settings messed up.
Human error, basically.
Awesome. Yeah. Because the gateway centralizes a lot of these security settings, it helps reduce those kinds of errors. One place to get it right, hopefully.
Okay, so summing that up. The gateway is like a multi-talented security guard. It defends against a whole range of different problems. It's not just directing traffic.
Exactly. It's your primary shield for your APIs in a pretty hostile digital environment, a strong layered defense.
Right. So we know why it's vital. Let's get into how. You mentioned policies.
Yes, policies are the key. They're the actual rules the gateway uses to enforce security. Let's look at a couple of really important ones. First up, managing API traffic through rate limiting.
Rate limiting. We touched on it for preventing resource hogging. Can you break down how that policy works?
Sure. So a rate limiting policy basically says, okay, you from this source can only make X number of requests in Y amount of time.
Like 100 calls per minute, maybe?
Exactly like that. The policy has a few parts. The calls, that's the max number allowed, the period, the time frame, like a minute or an hour.
Okay.
Then there's the refresh increment, how quickly that allowance gets reset. And crucially, the key type. What are we tracking this by? Is it an IP address? Or maybe an API key?
And using an API key is more specific, right?
Yeah.
It tracks a particular app or user, not just a machine's address.
Precisely. The key is that specific identifier being monitored. So each API key gets its own counter. This stops one noisy application from ruining things for everyone else.
Gotcha.
And it keeps the back-end systems from getting overloaded. So rate limiting. Fundamentally about fair use and stability, protecting against overload, intentional or not.
Makes total sense. So that handles the amount of traffic. What about who is making the request? That's another policy, I guess.
That's exactly right. And that leads us to the policy for verifying JSON Web Tokens, or JWTs. You see these a lot now, especially with external identity systems.
JWTs. Those are like digital ID cards, aren't they? They carry info about the user.
That's a great way to put it. They're self-contained tokens with verified info, who the user is, what they're allowed to do, their permissions.
Like a little passport?
Pretty much. So when a request comes into the gateway with a JWT, this policy kicks in to check it. First, token validity. Has it expired? Critically, has anyone tampered with it?
How does it know if it's been tampered with?
They have digital signatures, cryptography. The gateway checks that signature to make sure the token hasn't been altered since it was issued.
Okay, so it has to be current and authentic.
Correct. Then second step, checking user rights. The JWT contains claims, these statements about the user, like their roles or specific permissions. The gateway looks at those claims.
And compares them to what's needed for the API they're trying to access.
Exactly. If the permissions in the token don't match what the API requires, access denied, even with a valid token.
So it enforces least privilege, essentially. You only get access to what you're explicitly allowed.
Precisely. It's fundamental for secure token-based systems. It means the gateway can verify access without constantly having to phone home to the identity provider for every single request. Secure and efficient.
Okay, so those are some core policies. What about newer stuff? How are we enhancing security beyond these basics?
Good question. Threats evolve, so defenses have to as well. One big thing is OAuth 2.1. You probably know OAuth 2.0, it's everywhere.
Yeah, used for authorization all over the web.
Right. Oath 2.1 is the update. It tightens things up, makes it more secure, simplifies some guidelines to avoid common mistakes.
A more robust version then.
Yeah.
How does it work with the gateway?
So the basic flow is an app needs access to an API. It asks the user for permission. User says yes. Then an authorization server gives the app an access token, often a JWT, as we discussed.
And that token has limited permissions, right?
Exactly, limited scope. The app then presents this token to the API gateway when making a request. The gateway validates that JWT checks the signature, expiry, and critically, the scopes or permissions it grants.
Making sure it has permission for that specific action.
Correct. If everything checks out, access granted. So OAuth 2.1 provides the framework for getting that limited use token securely, and the gateway enforces its validity and permissions.
Got it. Standardized secure delegation.
And another major concept is zero trust. We hear this term a lot lately.
Yeah, definitely buzzing. What's the core idea?
It's simple but powerful. Never trust, always verify. It flips the old model on its head. The old way was often, if you're inside the network, you're trusted.
Which we now know is flawed.
Deeply flawed. Zero trust says, we don't care where you are inside, outside, you're not trusted by default. Every single access attempt needs strict verification, every time.
So even if I'm logged in, trying to access a new API still requires a check?
That's the idea. In the gateway context, it means every API request gets authenticated and authorized, regardless of where it came from or previous checks. The gateway is constantly verifying identity and permissions for that specific request.
What does that help practically?
It massively limits lateral movement. If an attacker does get in somehow, they can't easily move around and access everything else because each step requires fresh verification. It contains the potential damage, assumes breaches can happen anywhere.
Minimizing the blast radius if something goes wrong. That makes a lot of sense.
It really does. It forces continuous verification, making life much harder for attackers.
Okay, these modern approaches sound powerful. Let's shift to practical advice. What are the absolute must-do best practices for API security with a gateway?
All right, some key ones. First, enforce HTTPS. Always. No exceptions. Encrypt that data in transit.
Basic, but critical.
Absolutely. Second, use oath scopes and permissions carefully. Principle of least privilege. Only grant the minimum access needed.
Don't give out master keys.
Exactly. Third, use short-lived access tokens and use refresh tokens alongside them. If a short-lived token leaks, the window of exposure is small. Refresh tokens let clients get new ones securely without constant user logins.
Reduces risk. Got it.
Fourth, if you use API keys, limit their permissions strictly and always combine them with rate limiting. Always.
Double protection there.
And finally, this is super important. Enable detailed logging and monitoring. You need visibility. Logs help you spot weird activity, investigate incidents, and respond quickly. You can't protect what you can't see.
Log everything. Makes sense. These all sound like building layers of defense.
That's the key. A layered approach is the most robust.
Okay, great list. Now, we do get common questions. Let's tackle a few quick FAQs. We keep mentioning it, but why is rate limiting so vital again?
Right, it's fundamental because it stops abuse. Simple as that. It prevents one source from hogging all the resources, whether they mean to or not. Protects your back-end systems from getting overwhelmed. Ensures availability for everyone else. Key for stopping DOS attack.
And specifically for DDoS, distributed denial of service, where the attack comes from many places at once. How does the gateway help there?
Well, a gateway isn't a magic bullet for huge DDoS attacks, but it's a crucial part of the defense. By limiting requests per IP or per API key, it can throttle or block those distributed sources when their traffic hits the threshold. It helps absorb the initial shock and prevents the backend from collapsing instantly.
So it contains the damage somewhat.
It helps, yes. Part of a larger strategy usually involving specialized DDoS mitigation services, too.
And lastly, JWT's JSON Web Tokens. Just recap their main role in all this.
Sure. JWTs are the enablers for secure, stateless API calls. They do two main things: authenticate the user, prove who they are cryptographically, and carry their permissions, what they're allowed to do. The gateway's job is to validate them rigorously, check they're real, not expired, and have the right permissions for that specific request. Secure and efficient identity and access management.
Perfect summary. Now, bring it back to SEEBURGER, since that's my world. How do SEEBURGER solutions help organizations actually do all this stuff we've been talking about?
Well, SeeBurger's whole platform for API management and integration is built with this kind of security in mind. It gives businesses the tools to implement these measures effectively.
So things like setting up those rate-limiting policies we discussed.
Exactly. Easy configuration for rate limiting, seamless handling and validation of JWTs, full support for things like OAuth 2.1, and the building blocks you need for a zero-trust approach. It's about enabling secure digital business models.
And the core message is that strong gateway security is just non-negotiable today.
Absolutely paramount. Protecting data, ensuring services are reliable, defending the business. Our platform and expertise help companies navigate that.
And if listeners want to learn more, get deeper into the details.
We've got a great API security white paper on the website, SEEBURGER.com. It goes into more depth on all these topics. And of course, our expert teams are always there to talk specifics and offer advice. Just reach out.
Excellent. So wrapping up this deep dive, API gateways are critical for security. Policies like rate limiting and JWT validation are essential tools.
And modern approaches like OAuth 2.1 and Zero Trust really level up that protection.
Hopefully you, our listener, feel more equipped to navigate this landscape now. You understand the why and the how a bit better.
That's the goal, empowering understanding.
So here's a final thought to chew on. With everything getting more connected, systems talking to systems constantly, and threats always evolving, how do you think these core ideas of API gateway security will need to change or adapt for the future? What are the next big challenges?
Ooh, that is a big question. Definitely something that will keep shaping the field.
Food for thought. Thanks everyone for joining us on this deep dive into API gateway security. We'll catch you on the next one.